The rate of fuel consumption in gallons per minute recording during an airplane flight is given by a twice differentiable and strictly increasing function r of time t. This sounds like it's going to be a lot of fun. A table of selected values of r of t for the intervals 0 and 90 is shown below. So this is the rate, and it's the rate of fuel in gallons per minute. So at 0 time, you're burning 15 gallons per minute. At 20 minutes, you're burning 60, so on and so forth, so on and so forth. Using correct units, what does the integral from 0 to 90 of r of t dt represent in the context of this problem? Oh, that's not that bad. All right, so when you integrate a rate, you're going back to its original thing. So you're kind of getting rid of the per time part. So we're just dealing with gallons here, really is what you're doing when you integrate. So between 0 and 90, we are finding how much fuel we're going to use for the first 90 minutes. So which one of these is going to give us that? The total fuel consumed in gallons during the airplane flight from 0 to 90 minutes sounds good to me. The average, no. The fuel consumption rate, no. The increase, no. The maximum, no. So it's the total fuel. You have to keep in mind that if you integrate a rate, you are finding the total amount used. And that's what we're doing here. This problem is a lot friendlier than it had to be. Water is pumped into a tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing from 0 to 8. Selected values of R of t are shown in this table right here. At time t equals 0, there's already 6,000 liters of water in the tank, so that's nice. What does the integral of r of t represent in this situation right here? Well, when you integrate a rate, you are looking for basically the original guy, which is liters of water. So without saying a ton, when I integrate that, what I'm finding is the amount of water pumped into the tank over its first 8 hours. So the amount of water pumped in the first 8 hours. Okay? Not too bad. Now this is not going to be fun. Estimate 0 to 8, the integral from 0 to 8, using left Riemann sums. So since I'm not given a formula, I'm going to have to use left Riemann sums. And so that's going to be me kind of drawing out a particular picture. Now let me draw that picture out right here. All right. Okay, so let's just say that we have 3K, 2K, 1K. All right, so 1K, 2K, 3K. I'm at 0 right here. I'm at 1. I'm at 3. I'm at 6. I'm at 8. Okay, at 1, I'm at 3K, so 3.5 right there. Now I'm using left Riemann sums, so that's why, by the way, this looks the way it looks, okay? So what else am I doing? At 3, I'm focusing on the fact that 1 is 28, so somewhere up here, that's going to look like that. At 6, I'm focusing on the fact that 3 is 23K, so somewhere up here. And at 8, I'm focusing on the fact that 6 is 1.7, so somewhere up here. Okay, so let's label all this stuff. Okay, let's label all this stuff. I have a length of 1, length of 2, length of 3, length of 2. Here I'm at, so 3,500 right here. Here I'm at 2,800. Here I am at 2,300, and here I'm at 1,700. So using left Riemann sums, what I'm going to do is I'm going to do 1 times 3,500, like that, plus 2 times 2,800, plus 3 times 2,300, plus 2 times 1,700. And of course, everybody knows that that's 19,400. I didn't use a calculator by pausing my video. So that's what my estimate is. That is my estimate of the amount of water pumped into the first 8 hours. Now, based on this estimate, how many liters of water are in the tank after 8 hours? Well, I know that I started out with 6,000, and I know that I added roughly 1,900 or 19,400. Okay, adding those two guys together, I get 25,400 liters. Okay, so that's how you do that problem right there. Not the most fun problem in the world because no one likes Riemann sums, but hey, everybody loves Riemann. They just don't like his sums. Thanks for watching. Thanks for watching. Lucy is painting a fence at a rate of r of t equals 250 minus 5t square feet per hour, where t is the number of hours since she started painting. If the fence is 1,000 square feet, how long will it take her to finish painting the fence? Round your answer to the nearest minute. Ugh. So we have the rate, and the rate is square feet per hour. Okay, we need to integrate that to find out how long it takes to cover everything that it is. Not only that, okay, so we're going to integrate that. We know that this whole thing is going to equal out 1,000. So the integral of the rate is going to give me what is covered, knowing very well that it's got to equal 1,000. I don't have an initial condition, except that I do know it's 0, 0. I don't know if that's going to help me, but I'm just going to integrate with respect to 0 and t. Okay, and that'll, with it limits at 0 and t, capital T, and that should help me out. So integrating this guy on the left is going to be 250, not 200, but 250 t minus 5 over 2t squared with limits at 0 and t. That's got to equal 1,000. Okay, so doing this guy, I get 250 capital T minus 5 halves capital T squared minus 250 capital 0 minus 5 halves double capital 0 squared equals 1,000. You go away. So we end up with 250t minus 5 halves t squared equals 1,000. All right, so let's do this. Let's multiply everything by 2 to get rid of that. Let's multiply everything by negative 2 to get rid of that. So that'll be negative 500 t plus 5t squared equals negative 2,000. Let's add 2,000 to both sides and rearrange things so we have 5t squared minus 500t plus 2,000 equals 0. I can rip out a 5. So I'm going to do that. 5t squared minus 100t plus 400 equals 0. Ugh. All right, I don't know if that's factorable. I don't think it is, so I'm going to have to use quadratic formula. T equals negative b plus or minus the square root of b squared minus 4 times a times b all over 2a. Invisible 1 is my a, negative 100 is my b, and 400 is my c. So t is going to equal negative 100 plus or minus the square root of negative 100 squared minus 4 times invisible 1 times 400 all over 2 times 1. So I'm not going to pretend like I know how to do this. I'm just jumping straight to a calculator and find out that that square root ended up being 91.96 all over 2. So we have two options here. Okay, 100 plus 91.96 all over 2. That's supposed to be a 2. And 100 minus 91.96 all over 2. Okay. Now, here's what we have to keep in mind. Okay, that minus represents a time. That's not going to make sense. So we're going to have 191.96 all over 2. Okay, that is going to be, I don't know, 95.83 according to the internet. 95.83. Now that is hours. To convert that to minutes, you multiply 60. Multiplying that to 60 is going to get you roughly 5,750 minutes according to the internet once again. So not the prettiest problem in the world. Not the prettiest problem in the world, but we did it and we had so much fun.